Okay, gentlemen, so here's how this is going to work. I am going to go through this homework. And yes, it is a little bit longer, although you did have plenty of time to work today in class. But going through this is going to help you when you do your IA tomorrow and or your New York State test. Obviously, we don't know exactly what those questions are going to look like, but given our previous year's experience, we have a pretty good idea that this is stuff that you should really be paying attention to for the New York State exam and also for your IAs. Okay, so a consumer agency tests tires so that shoppers can compare brands. The dot plots and box plots below show the results of the testing. So over here I have my dot plots, and over here I have my box and whisker or just box plots. Okay. And so what I'm looking at is the average tire life in thousands of miles. So for example, for the Star Tire Company, one of their dots has their tire life as 41,000 miles. And we go all the way up here to 50,000 miles. So we are going to use the box and whisper plot to do, excuse me, a 5-number summary for each brand. So the minimum here, the minimum for the Star Tire Company was 41,000 miles. Quartile 1 for the Star Company is 44. Quartile 2, or the median, that median number is 46. It looks like it's going to be the same for the other company, although the data is spread out quite differently. Our next quartile, quartile 3, is 49. And of course, our maximum is 50,000. And we'll do the same thing down here for the Dora Tire Company. We have 44. First quartile is 45. Our median, 46. Our next quartile is 47, and our maximum here is 50. And there's a lot we can tell about this information. First, let's talk about the range. So the range is the maximum minus the minimum. Okay, so I'm going to take over here for the Star Company. I'll do that company in red. We will do 50 minus 41. So their range is 9,000 miles. Okay, Star. And then let's do the Dura Company. And their range is 50. Oh, you know what? I'm looking at this and it looks like I made a mistake. So I'm going to go here, erase that, because the Dura Company only went up to 49. All right. And so this is an example of what I was telling you guys today of making a silly mistake because you're rushing a little bit. So keep that in mind as you work tomorrow. So I'm going to go 49 minus 44. And my range here is 5,000 miles. Okay. And let's take a look at the interquartile range. Now, if you remember from today, the interquartile range is the range in this box, okay? And up here, it's the range in this box. And so for the Star Company, I'm going to take a look. Oh, I got rid of my things. So I have 44 and I have 49. Okay, so I'm going to do 49 minus 44 equals 5. So the IQR here, the interquartile range, is 5,000 miles. The interquartile range for the Dura Company, I have the first quartile is 45 and the second quartile is 47. So I'm going to go ahead, Dura is 47 minus 45 equals 2. So my IQR for Star Company, for the Dura Company, sorry, is 2,000 miles. Now, what information can I learn from this? Well, the first thing I'm seeing is they both have the same median, and that's where I know that this box and whisker plot will help me understand more about a data set than simply looking at the median, because we have the same median. I'm looking at the Dura Tire Company, and their outer quartile range is small and their inner quartile range is small. Whereas the Star Tire Company has a long range. We have the outer quartile range goes from 41 to 50, and we have the inner quartile range, which is as long as the entire range of the Dura Tire Company. And so what that tells me is, although the median is the same, the Dura Tire Company has less variability. So I'm not going to have a tire that I say, oh, this tire could last me anywhere from 41,000 miles to 50,000 miles. What I do have is, okay, if I have this Dura Tire Company, that average of 46,000 miles, I have a pretty good chance of the tire lasting really close to that average because there's so much less variability in the data. Okay. So make sure you have all this information and we'll move on to the next problem. Okay. Rob wanted to compare the effectiveness of two different brands of fertilizer, Maxi Growth and Sprout Up. Maxi Growth and Sprout Up. He put Maxi Growth on one cornfield and an equal amount of Sprout Up on another. At the end of each month, he measured the heights of 20 plants at random from each field. Rob made stacked dot plots and box plots. So I have my dot plots here, and then these are my height in inches. And then I have my box plots here, one for Sprout Up and one for Maxi Grow. So determine the median range and interquartile range for each brand. So for Sprout Up, all right, my median, I can just go right here. Boom, my median here is 36 inches. My range, so I start over at 40, I go from 30 to 40. So it looks like my range here is 10 inches because I did my maximum minus my minimum. And my interquartile range, 34.5, that looks like about 34.5 to 38. So I would do 38, excuse me, minus 34.5, and I would get 3.5 inches. So my IQR here is equal to 3.5 inches, okay? And then we'll take a look at Maxi Growth. Okay. My median for Maxi Growth is the same. It's actually 36 inches. My range is from 32 to 40, so my range is 8 inches. And my interquartile range is from, oh, it looks like I made another silly mistake. I'll go back and fix that in just a moment. Is from 34.5 to 38. And so my interquartile range here is 3.5 inches. And I'm sure some of you guys were a little frustrated that I messed this one up. All right, IQR. Sorry, so I'm going to look for my interquartile range for the Sprout Up Company, and that takes me from 33 to 38. So 38 minus 33 is going to be my IQR here is equal to 5 inches. All right, and now that I know I messed up there, let me make sure I did everything else on this one correct. 30 to 40, that's 10-inch range. Median 36, okay, range here from 32 to 40 is 8, and then I do have my 3.5 interquartile range, all right? So if you're wondering why does Miss Syed always make me go double check my work, well, this is one reason, because we all make these silly mistakes sometimes. Irene collected data on the test scores across several grades. Okay, so I have my grade 10 down to grade 7. Irene states that because the range and IQR for grade 7 is the largest, that grade tends to have the highest test scores. Do you agree with Irene's statement? If so, explain why. If not, correct her statement. So I'm looking at grade 7 here, okay? And so their range is from 30 to 100. So they have a range here of 70 points, okay? And their interquartile range, it looks like about 58 to 89. Okay, so we'll say from about 58 to 89. 99 minus 58 is going to be 31, I believe, 31. Yep. Okay, so my IQR here is equal to 31. Now, one thing she didn't include in her evaluation is the actual median. So the actual median here for the 7th grade looks like it's about 74. Okay. And I'm looking at these box and whisker plots, and I'm saying right away, I actually don't think that the 7th grade is the grade that trends toward the highest scores, okay? So let's take a look at my other medians. In 8th grade, my median looks to be about 76. My median in 9th grade looks to be about 87. And my median here in 10th grade looks to be about maybe 75, okay? And the other thing that I want to take a look at is the interquartile range of each of these. And I have my eye on grade 9, and I have my eye on grade 9 because the information I know right now is that at least half of the grade scored 87, scored above 87, okay? So I know that 50% of these kids scored above 87, and then I know also that the lower 25% of these kids all actually scored higher than the 7th grade. So they have the smallest amount of variability. And let me just see if I can explain this. So if I draw a line here, this part represents 75% of the 9th grade. So I know that 75% of the 9th grade scored close to 80, scored something like a 78. So right away, I'm saying no, this 7th grade did not have the highest scores. In fact, I think 7th grade probably trended toward having the lowest set of scores. So I would say 9th grade had the highest score trend, while 7th grade had the most variability in scores. All right, so you have the kid in 7th grade going from 30% all the way up to 100%. And the lowest score I have here in 9th grade is just a little bit below 70. Okay, so 9th grade were really the stars of this particular test. All right, we'll take a look here, and we are going to find the median range and interquartile range for each of these. So my median here for A, I'm going to kind of draw a little line. So it goes, they're going by 4. So I'm going to go ahead and say my median there looks like it's about 35. My range is 58 minus 22. So I'm going to go, okay, 58 minus 22, and that's going to give me 36. My range here is 36. And my interquartile range looks like here I'm at about 50 minus about 25. And so I'm going to go 50 minus 25. My interquartile range looks like it's about 25. For B, my median, boom, looks like it lands right on 32. My range here, this looks like it's 22, and this looks like it's 58. Yep, is again 36. And then my interquartile range, it looks like I'm at about 25 and then 52. So 52 minus 25 would give me 27. Here we have the median of, looks like it's the same above, 32. My range here, it looks like I'm going from about 22 to 58. So it looks like the same range here, actually, 36. And then my interquartile range, I'm going to say that's about 25. And this is about 46. Okay. So I'll say 46 minus 25 is going to give me 21. And let's take a look here. My median looks to be about 33. My range is, it looks the same again, actually. I have from 22 here to 58. So my range here is going to be 36 again. And then my interquartile range, it looks like I go 25 to 48. 25 to 48. So that would be 23. Okay. Take a look at that, double check me. If you come in tomorrow with a correction from something I messed up, that is totally fine. All right. Miguel and Tim are keeping track of their number of hits in a baseball game this year. Below is a sample of 9 different games for each player. Part A, calculate the mean and median for each player. Okie dokie. So I'll start over here with Miguel. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. All right, so I have here 27. And then how many games was that? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm going to go ahead and say, what is 27 divided by 9? And I know that that is 3. So I'm going to go 27 divided by 9 is equal to 3. All right, so that's Miguel's mean. All right, and so let's take a look at Tim. All right, so I have 5, 10, 18, 19, 20, 21, 22, 23, 24, 28, 32, 37, 42. Okay, so I have 42 also divided by 9, and that gives me 4.666666667. So I'm going to just go round it to 4.67 is Tim's mean. Okay, let me double check that. So it's 10, 18, 19, 21, 22, 23, 24, 28, 32, 37, 42. Cool. All right, so now let's calculate the median. Okay, so I'm going to use blue for the median. So we'll have Miguel's median. Let's go, he has a 0. He has a 2. I see another 2. I see a 3. I see another 3. I see another 3. I got a 4 and 2 5s. 5, 5. Okay, so let me count and make sure that I really have 9 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, cool. Now I'm going to go ahead and start at the ends. Okay, so my median here is equal to 3. So in this case, Miguel's mean and his median are the same. Sometimes that happens, sometimes it doesn't. All right, so let's take a look at Tim. And the lowest he had was 3, 3, 4, 4, 5, 5, 5, 5, 8. 5, 5, 5, 5, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and I will find the median here. And Tim's median is equal to 5. So what inference can we make about Tim and Miguel's performance for the rest of the baseball season based on their medians? Okay, so Tim has a higher median, and will likely outperform Miguel. Okay, and all of the data pretty much backs that up. Okay, we are going to review some more percentage problems because we just cannot get enough. And during this part particularly, I think it would be fine for you to use your calculator at home, keeping in mind that in book 1, you will not have a calculator, and in book 2, which is tomorrow, you will. Okay, so Elijah decided to fly first class to London. Before a 6% tax, his ticket cost $8,162. What is the total cost of the ticket? Okay, so good old-fashioned OPN box. Okay, and in this case, since this is before my tax, the original here is 8,162. And my tax, I had a 6% sales tax. Okay, so now I'm going to find my new price. And I'm going to use my handy and always trustworthy. So my original times percent equals new. So my original is 8,162 times, and this is where I'm putting a 1.06. So that represents the increase. Okay, and you can use your calculator. I'm going to use mine. 8,162 times 1.06. And for this, I have $8,651.72. 51.72. Okay, and let's see if that's an option. It is option C. All right. Pia bought a pair of shoes on sale for 30% off. If Pia paid $63 for the shoes, what was the price of the shoes without the discount? Okay, so this is one of these find the original. So my OPN chart here says, I don't know the original. I know that we had a 30% discount, okay? And I know that what we ended up paying was $63. So the original times the percent is equal to 63. Okay, so my original here is what I do not know. My original, we'll call that X. And if it was 30% off, that means that I paid 70%. So my X times 0.7 is going to give me 63. And if I divide both of these by 0.7, divided by 0.7, I'm going to say 63 divided by 0.7 equals. And I have my X equaling $90, okay? And that kind of makes sense, right? Because if I have 30, 30, and 30, I get to about 90. So if I take about 30% off, I'll get down to about 63, okay? So my answer here is 90. We'll keep moving on. All right, let's see here what's going on with Sam. Sam's employer deducts, which means takes out, 20% in payroll and state taxes from his base salary before writing his paycheck. Sam's monthly paycheck is $1,600. What is Sam's salary before the deduction for payroll and state taxes? So some of you guys may have started working. Some of you might be old enough. But when you start working, you will make a certain salary, and then you'll see that your paycheck is actually a little bit less than that because your employer has to take away state and local taxes before they give you, or most of the time before they give you the paycheck, okay? So my original, my percent, and my new. Okay, so in this case, the original is what I don't know. Okay, I know that we deducted 20% before we got to this new, which is 1,600. All right, so I have my original times my percent is equal to my new. All right, and in this case, again, I don't know the original, but I know, sorry, I had a little glitch. Okay, so since 20% was taken off of the paycheck, we know that 80% is what Sam is getting, okay? And we know that 80% is equal to $1,600. So I'm going to divide both sides by 0.8, divided by 0.8. And when I divide 1,600 by 0.8, I am going to get $2,000. So his salary before these deductions is $2,000. Sam puts, I think I messed that up a little. All right. So Sam puts 1/5 of his paycheck into a savings account each month. How much does he save each month? How much does he save each month? So we're talking about his paycheck. So his paycheck is $1,600, okay? And so 1/5 of that is going into a bank account. I'm actually just going to divide this by 5. So I have 1,600 divided by 5, 1,600 divided by 5, and that gives me $320. Okay, so he saves $320. All right, we are going to keep chugging along this homework. So a submarine is 105 feet below the surface of the water. It is 105 feet below the surface of the water, so that's a negative. And it begins to ascend, so that means it's going up at a rate of 3 feet per minute. After how many minutes will the submarine be 81 feet below the surface? Okay, so for my key information box here, I'm going to draw a little diagram. Okay, so this is my ocean, which is also 0. All right, and I have my submarine down here. Okay, and it looks like kind of a cigar, but that's okay. All right, and so the submarine starts here at a negative 105 feet. Okay, and I know that I'm going up at a rate of 3 feet per minute. And I know that when I land or when I stop, I'm going to be at negative 81 feet. And so the question is, how long does that take? Okay, well, first I need to find how far of a movement that is. And so I'm going to find the difference between 105 and 81. So I'm going to go 105 minus 81. That's going to give me 24, okay? So I know I have this movement of 24 feet, and I know that that's at 3 feet per minute. So I'm going to take that 24, I'm going to divide it by 3, and I know that 3 goes into 24 7 times. 8 times, forgive me, 3 goes into 24 8 times. Okay, and so it takes 8